A macro language is used to provide syntax for defining macros. Linkers and loaders are again a system software that requires these operations to be carried out. A function prototype is one which is an indication to the C compiler that there is an existence of function definition in the future. Hello everyone, it is Dr. Ravi Kumar YB, Associate Professor, Vidhyaashram, First Grade College, MYSURU, the Temple of Excellence. In today's session, you are going to learn about the macro processors and how the assembly language macros are going to be defined in more detailed information. That is, these assembly language macros plays a significant role in the expansion of these codes before the actual compilation begins. The first operation, that is an assembly language macro, is a template whose format represents a pattern of 0 or more assembly language statements. That means any macro which we define is common to many of the languages, or it may be common to only one of the languages, that is only for assembly language or for C language or for any of the COBOL programming language. In all these cases, you will come across the same template. That is, the template may be the name of that macro, followed by macro is a keyword, followed by name of the macro, that is limit. All these are certain types of statements which is ending with end. That is the set of statements that goes on between macro beginning and macro ending. This is the simple template which is common to many of the programming languages. In that case, a macro language is used to provide syntax for defining macros. That is, for defining a macros, we need to have a syntax of this format. That is, macro is the keyword followed by name of the macro. Within that, you can have any set of statement which can be incorporated for expansion of those actual program before the compilation begins. That is called as the syntax of the definition of macro. When a sequence of assembly language statements can be represented by a macro call is inserted into the assembly program source code where the assembly code would otherwise go. That means before the actual expansion, the preprocessor directives checks whether there is any macro expansion required for any of the programs. In case if it comes across any macro expansion needed or written by the programmer, then obviously the program, that is the source program, is given to the macro processors. These macro processors are also called as preprocessor directives. These preprocessor directives will allow you to incorporate the body of the macro in place of the call, that is macro call, where it is done. That is why we call it as the macro call which is inserted into the assembly program. This macro call enables the code segment which needs to be incorporated in place of the macro call, that is in line with the function definition. That is how the macro expansion takes place. Next, similarly, a macro facility is used to interpret macro definitions and expand each macro call as it occurs with the requisite pattern of assembly language statements. Please remember carefully, each macro call occurs according to the requisite pattern of assembly language statements. And that means if there is any COBOL programming language, it works according to the programming language COBOL. If there is any assembly language or an intermediate programming language, it works according to that. So if there is any ALGOL programming language, then it works according to that. That is, the pre-processing takes place according to the requirement of the language specifically required for the programmer. In that case, providing the expanded version of the source code which is ready for the assembler. Once it is completely expanded, it is given to the interpreter or to the assembler. That is how it is going to be done. Then the definition states that an assembly language macro definitions can be predefined and placed in a macro library and can be included inline. Please note that it is inline. The word inline states that the entire body of a macro definition is placed in place of call where it is guided. That is, where actually the macro instruction is called, the definition of the macro is placed and then it goes on accordingly with the assembly language program. So we have defined the macro definitions as a macro definitions can be predefined and placed in a macro library. That means we can place it in a library and we can use it whenever it is required, even based upon the conditional macro operation. And even we have the other directives of operation, as I have already told you in the previous sessions, that ASH pragma directives. That is ASH pragma, startup and exit are the options we have to turn on and turn off the features which can be incorporated when it is required and which can be ignored when it is not required. So even those kind of options are available with the higher level programming languages like C, but not in assembly level programming languages. In few of the languages, like in environments, especially in environments like GCC environment, the macro is not supported. And of course, it is very much essential for many other programming environments like Borland Corporation and Turbo C environment and Turbo CC environment. All those are environments that requires the usage of macro for the purpose of expanding the original source code or a source program into the more expanded version. Then, if you look at this, you will clearly say that the macro library which you have added into it will be added or inserted at the time of macro facility, that is with source code. Once when the source code is ready, we will bring it to the next level, that is the expanded source code, which is it is not in expanded form. Once when the library is incorporated, it becomes the expanded source code. Then it is given to the assembler. The assembler then takes the expanded source code and generates an object module. This object module in turn looks for any other module which is required to be incorporated with the help of a linkage editor, also called as a linker. Linkers and loaders are again a system software that requires these operations to be carried out. That is, that those system softwares are required to carry out these operations. Once when the object module is generated, we will move on to the load module, wherein the loader comes into the picture, and the loader is another system software that performs the execution operation. That is, before the commencement of actual execution, these types will go on. So if that is the case, let me take you into the format of this macro definition. Here you will see that this is the header of the macro, that is optional label is there. Then you have a macro. Then you have the set of parameters, then macro name followed by ampersand operator, that is parameter list. A set of statements follows immediately after that. Then you have an end, which is again an indicator for the end of the macro definition. So we have the end statement here. This is the body of the statement, that is the body of the macro. Then we have a prototype statement like this. The prototype indicates that it is the header, similar to the function definition, that is function name int secured percentage is the name of the function. This is a prototype. This is a prototype that indicates that there is a function call, there is a function definition exists in the future reference. This is called as a function prototype. Function prototype. What is the meaning of function prototype? Let me clarify you that. That is, A function prototype is one which is an indication to the C compiler that there is an existence of function definition in the future, so that there would not be any error in case of top-down approach. In the same manner, we have this macro prototypes that this enables the assembler to place the macro definition in place of macro instruction in line with it. That is the reason we have the prototype here. Then the prototype, after that we have a prototype body, that is the macro body, which is finally ended with end as an indicator of the end of a macro definition. Then moving on to that, we have one of the example here, that is the name of this is a macro. We have a putc which prints the character, which receives two parameters. One of the parameter is character which needs to be printed, and the device which indicates that from which device we need to receive the input, that is ampersand DEV. Then we have STA, which corresponds to the store accumulator, which needs to be saved, that is put C save. That means it has to be saved. It is linked with this. There is a future reference. That means it has got a forward reference. Now, load character. Which character? The character which is passed as a parameter to it is passed here, load character. Then put C loop. We have a label J here. Then we have a put C loop here. Where is that put C loop? That is present in this macro. It is present in this location of this macro definition. Again, it is a forward reference there. Then once when it comes to this put C, it comes across the information which is present in this, that is reserve 1 byte, 1 word of information, that is RESW, reserve 1 word of information. Then it takes that TD ampersand DEV, that indicates that from which device the system needs to read this character, that is going to be mentioned here. Jump if equal, when, if they are equal, if the condition is satisfied, put loop. Where is that put loop? Again, it is here. It jumps to this location, right? Then we have WD. Then we have write the character, to write the input which is received from the device. Then load the accumulator with put C save, that prints the character and places it into the expanded source code. If that is the case, let me take you into the details, more detailed information. In our assembly comes with a macro facility which you have come across, that is the macro library, that is the macro facility which you have here. Now, for handling this format, then put C can be used in a program in the same manner as an instruction. For example, if the definition of put C is in the macro library or included in line with the assembly code, then the preprocessor will be able to expand any statement whose opcode is put C. That means if you have a put C here, anything which comes across the put C, then everything is placed, the statement, the entire body of this is placed inside the location in line with the instruction where it is used, that is where put C is used. Then we have jump if equal, the same thing. This is the macro I am using here. Put C is the name of the macro. Then it places the entire thing, which is that line, which is that character X, which is the device. I am using the character X with 04, and which is the device. 04 is the ID of that. Which is that character? I want to print X. I want to place X into that. Then which is that device that is going to present the input X character 04, identified by 04. Then it goes on according to that. If you look at this, you are clearly able to see that the line comma X is placed in place of this put save, put C save. If you look at this, we have the function which is defined there, ampersand character. Which is that character we have here? We have the character which is equal to line comma X. Then we have TD, which is that device that is going to present input, that is X identified by 04. Then it is placed according to that. So it is pasted in place of put C. So this is the macro, and with these are the definitions of the macro which is going to be placed according to the macro instruction which is defined in a program. So with this, we are going to conclude another example which I considered in today's session to explain the concept of macros. With this, we are going to conclude the session of macro and the macro conditional statements and other type of directives such as this include statements, other directives, pragma statements and other files. All those are certain types of macro definitions which are supported in high-level languages as well as in the assembly level languages. But there is an environment called GCC environment which does not support certain types of macros. So you have to be careful when you select the environment in which you are going to use the macro operations. Thank you very much. Thank you one and all. With this, I am going to conclude this session. If you come across any questions or doubts with respect to the concept I discussed in today's session, kindly come back to me in the live session so that I can clear all of your questions in that session. Thank you. Thank you one and all.